The objective of the study is to create an artificial intelligence capable of procedurally generating video games that are playable for the Game Boy. The Game Boy is a Nintendo handheld gaming console released in 1989, and it is the third best-selling console in history. Procedural generation is the idea of creating data using computers, and this kind of process gets used to create content for games. And here we're trying to use it to create an entire game.
So here's a quick overview of the project. In general, academic game generators rarely produce artifacts that game developers can use. Even though game generation systems have produced interesting results, they are not actionable for developers. We want the artifacts to be useful and usable. To do this, we need a game representation. Therefore, we implemented a game generation system targeted at generating playable ROMs for the Game Boy. The system should act as a bridge between research and active game developers. We want this relationship to be bi-directional, so the generator has to learn from the community, while the community can contribute to the generator.
So a big concept in AI development that this project revolves around is the idea of the orchestration problem, which is the idea of generating several types of media that mesh well together with one or several artificial intelligences working together. In this case, video games are made up of 6 elements: audio, visuals, narrative, levels, rules, and gameplay. Being able to simultaneously generate different genres of content to create a coherent experience could really change the way that game development happens in the future. It could kind of streamline the process and help people create much more diverse games and like entire experiences while having to do a lot less manual work and letting AI take the load. The chart to the right illustrates the way that content was generated by the program in the 1.0 version last year. It involves several generators creating content together like an orchestra, hence the name, the orchestration problem. So the first thing we're going to cover is the features that we developed that will go into the algorithm for game generation.
Yeah, so one of the first things we did was make enemy AI. So with the help of GB Studio's different functions, I was able to make several enemies with behavioral patterns that we can teach to the generator. Of these enemies, my favorite would probably have to be the one that chases the player, which I made by storing the player and enemy's positions in different variables and then creating 4 different event groups. You can see one of these in the bottom left. And these event groups are labeled left, right, up, and down, and they compare the enemy's coordinates with the player's coordinates and then move the enemy accordingly. If you look at the bottom of the if statement, there's a function incrementing the variable subcounter by 1. And what this does is it sets off an if statement at the end of my code that makes it so once the enemy takes 10 steps, it gets tired and then pauses for around half a second. Other notable behaviors that I made were random movement, which makes use of a random number generated between 1 and 4, enemies that patrol a certain area, and then of course enemies that swing a sword and shoot bullets.
So a feature that I developed is a real-time combat system. Real-time combat is a lot more complicated than turn-based games, and because of the serious hardware limitations of the Game Boy, it only showed up in select games developed for the original Game Boy, such as The Legend of Zelda: Link's Awakening and Final Fantasy Adventure. So I designed some simple enemy movement, one that moves randomly and one that targets the player. And I created this attack function with a sword that points out of both the player and enemies when they attack and damages anything that the sword touches. And the final feature that I developed for this proof of concept was a health variable such that the player character can take up to 4 hits, and every time it takes a hit, the health variable goes down, and once it reaches 0, the character actually, well, quote-unquote, dies, which is just disappearing on the screen. And these features are common for a lot of games with developed real-time combat systems. Another concept that I developed was cutscenes. I've created one that I will play on screen right now. Basically, the idea of this cutscene is that when the player character touches an invisible trigger, another computer-controlled character shows up, moves towards the player, and displays some text, and then moves away. Cutscenes are really integral to games with storytelling because it can help with exposition or to move the story along without forcing player interaction, if you will. It just kind of lets the game or certain elements of the game play out a bit more like a movie.
So yeah, what I focused on was improving the lock and key system and trying out mechanisms for the generator, and also creating puzzle elements to it. So yeah, the first puzzle I did was guess the combination puzzle. Basically, you press the supposed levers, buttons, whatever you want to name them, in a specific order, and each of them will react differently depending if you pressed it correctly. If you don't press them correctly, the variables will reset to 0, resulting in starting the puzzle over again. And yeah, there's a version 2 of this, but essentially it's without the resetting. It's without resetting the variables, so you can continue even though you might have guessed incorrectly. Next, I decided to do a memorization puzzle. So when you enter a scene or room, the player stops in his tracks, and as you can see in the top right corner, the other actors start to light up, representing or showing in which order, or you're supposed to memorize in which order they lit up. And yeah, it's the same as the version 2 of the memorization or the other puzzle. It doesn't reset, so you can continue doing it even if you mess up. And yeah, then I started to work on the mechanisms for the generator for the games, and I decided to test out whether interacting with an actor and making a variable true will go on to another scene. And as you can see here, the player is interacting with this actor, and what's supposed to happen is when you interact with them, they disappear and you progress. And so yeah, when you move on to another scene, if you interact with an actor here or in the second image, essentially you have two options. They tell you if you're good, if how you're feeling. Your two options are good, but if you've interacted with the actor previously, it will give a different result, or it will say something different, which results in secrets, that can be added to the generator to give it more well, yeah, that's it.
All right. The final feature that I worked on developing was some level design with a tile set that we commissioned from pixel artist, and so I designed some pretty simple levels that I felt might show up in a Game Boy game with this kind of tile set, if you will. And the idea behind this is that the previous version of the generator only had human, manually created levels. But if we were able to use tile sets to just feed as many good-looking levels as possible into the generator, then it would eventually be able to create its own levels, and that would add a lot more diversity in gameplay between the games. to the experience.
Cool, thank you, Alex. So we're now going to talk about the audio generation implementation of the project. So you might be wondering how audio even plays a role in game generation in Game Boys. So if you ever played games like Super Mario Land or Pokemon before, there's always some background music playing. It's always like when the player performs an action, like jumps or opens a door, or even when the player dies, there was always a sound effect. And one of the main purposes of these sound effects, aside from the aesthetic function, is the engagement of different senses that enable those visual impairments to also play the game as well. So before talking about the tools we use, it's important to understand what a music tracker even is. So a music tracker is essentially a type of music sequencer software for creating music. And so this music is represented as discrete musical notes positioned in different channels as discrete chronological positions on a vertical timeline. And so some of the audio generation tools we use include OpenMPT and Milky Tracker. And so these tools are fairly old, but we do enjoy working with older forms of software to find modern uses for them so it doesn't become e-waste. And adding on, these tools are also used in Game Boy samples to create actual sounds using the GB drum kit. Also, when creating the sounds, these musical notes are represented using hexadecimal numbers, which include numbers 0 through 9, and then A through F, where A represents 10, B for 11, and so on and so forth. So these are screenshots of a sound I made directly from the music tracker Milky Tracker, which is one of the audio generation tools that we used. So in the first red circle, it highlights C sharp, which is a note that is very similar to the sound of that of a piano. The second circle highlights the channel note that note is located in. And so the below screenshot is a representation of the wavelengths for the same music notes shown above. So essentially, the above screenshot is where I would edit the notes, and the screenshot below is just a helpful representation of how loud the sound is during one loop of it. And an important note I want to make is that all of the sounds we're making are templates for the generator. And so after we create these sounds, we randomize them in the generator so they appear at random intervals. So on the left is the sound from the previous slides shown, and I'm now going to play for you how that sound sounds. Yes, that sound is like a creepy music sound, which can be used when the player may be walking down a scary alley, or it can be used to build up suspense in the game. I'm now going to play you the sound to the right, which is a level up sound that can be used when the player advances to the next level of the game. So the first step before we pass sounds into the generator is to make